Okay, so the last one here is our standard form for conics. So when we learned circles, we learned what was called the standard form or the standard equation for circles, right? And it looked kind of similar to this. It was actually, I'm gonna write it here for you. It's actually, we got it from the distance formula. We derived it using the distance formula. So let me show you how you can use the equation editor. This is kind of a little bonus. If you're in a Google Doc, you may already know this, but you can use the equation editor to write mathematical text. So if I go to Insert and then go to Equation, it's going to give me a little light blue box, text box, where I can start typing some stuff in. So I'm going to type x minus h, and then to do squared, you can do it a couple different ways. You can use this, like you can say that I want to do something squared, and it'll give you, oops, it'll raise you to a power. You can also use what we call the caret key, which is Shift 6. It's above the number 6 on your keyboard. So if you go Shift 6, it will give you a power there. Looks like I have a space that I don't need. Okay. And then I'm going to go plus. And we got y minus k squared. And then we had equals r squared, right? This came from the distance formula. This is how we got it. And this is what we called standard form for the circle. So when we get the similar equation for a parabola, it looks kind of similar. It has similar pieces, right? Like the x minus h piece and the y minus k piece. We don't have a radius, obviously. This also comes from the distance formula. If you remember when we did that construction with parabolas, we said the parabola is all the points that are the same distance from the focus, the same distance from the focus as they are from the directrix. So the derivation for this form is a little bit harder to get than this one. It's a little bit more confusing, but it still uses distance formula, which is why we see these different squareds. Also just spotted a mistake. We need to get rid of this. That is not right. This should be a 4p, right? Because in a parabola, you're only going to have one squared variable. Anyway, so that's kind of why this is called standard form a lot of times, is because this is standard form for a circle, and we really only have, like one form for a circle. I guess there's more than one. That's not true. There's more than one, but this is kind of like the one that makes the most sense for a circle. And so we want to be able to have a standard form for all the conics. That kind of makes sense. And this would be the standard form for a parabola if we're talking about, the conic family. But since there's already a standard form for polynomial functions, again, we get into the problem where we're using this word standard too much, and that can be confusing. So we've been calling this focal form because you can actually see the focal width. So let's talk about that really quick. We have two versions of these, because when we're actually talking about like a conic section, we're not talking about functions anymore. These don't have to be functions. They're just relations between x and y. So here, up in these other forms, we pretty much had functions, right? F of x, f of x, f of x. Because all these parabolas passed the vertical line test, they opened up or down. In this case, though, we have parabolas that can open up sideways. Left or right, which wouldn't be functions. So there's two versions of this. There's one for the up and down parabola, and there's one for the left-right parabola. Now, if you want your parabola to open down, that's going to have a negative right there. If you want your parabola to open left, you're just going to have a negative there. So that's kind of how that works. This wouldn't be standard form, obviously, but sometimes you'll see a negative over here. There's so many different ways we can arrange these variables. That's why there's so many different forms, but the reason why we look at them in different ways is because they each have important information for us. And this one, again, the important information is focal width. You can actually see that focal width right here, that 4p. So h and k is still your vertex, just kind of like in this one. The difference is here we just take the k. Here we have to take the opposite of what's in here, because this is like negative k or opposite k. 4p again is the focal width, and then p, just p by itself, is the distance from the vertex to the focus, or from the vertex to the directrix. Okay, so let's jump over into Desmos and let's graph it up, and let's take a look at the different pieces here. Okay, let's start with the vertical parabola. We're going to have x minus h squared equals 4p times y minus k. Okay, well, we're going to make sliders for all those, and they, again, default to 1. So our vertex here is at 1, 1, obviously, 1, 1. And then remember that 4p is the focal width, okay? I'm going to do something kind of a little tricky here. I'm going to add a point for the focal width. So check this out. What I'm going to do is I'm going to do, I'm going to put the vertex in, right? So the vertex will be 1, 1. Okay, so you can see that point. That's the vertex. And then I'm going to grab another point that's similar. I'm still going to do this 1, 1, but just check out how tricky this is. The focus is going to go up here somewhere, right? It has to be kind of above the vertex. So what I'm going to do is I'm going to take the y coordinate of the vertex, and I'm going to add whatever the p value is, right? So p is 1 in this case. So I'm going to do 1 plus p, okay? And we're going to label this guy as the directrix. Pretty sneaky, right? So if I change p, I change the focal width, but I also change the distance to the directrix, because p is the distance from vertex to directrix. So that's kind of cool. Now, if I'm going to change this, I would actually have to change it to h and k, so that if I change where my vertex is at, that the focus will follow it. So I'm going to go hk here, and I'm going to go hk. Again, pretty sneaky here, but now if I change my h and k, my directrix will go along with it. It's always going to be p away from the vertex. So this distance right here from the vertex to directrix is called p. It's this guy. So if I want to set it at 1, notice they are 1 apart now. This would be 1 and this is 2. If I want to set p at 5, let's go 3 actually, so I'm not off my graph. Now it's 1, 2, 3 away. Kind of cool. Okay, I'm going to do the same thing with my directrix. Okay, so I'm going to do the height of the vertex, which would be x equals, because it's a vertical line. The height of the directrix, k, minus p, because it's going to be p away. Whoops, sorry, not x equals. I want y equals. All right, cool. So now, again, p is the distance from the vertex to directrix as well. So 1, 2, 3. And you can follow this if you want. You can jump back in here. This actually tells you, hey, right now y is equal to -2, which is cool. Oh, shoot. This is the focus, guys. I'm sorry. You guys are like probably screaming at your screen right now, like, Mr. Lowry, that's not the directrix. Okay, this is the focus. Sorry. Okay, now we got it. Pretty cool. So yeah, let's mess with this a little bit. Let's change the vertex. Let's do 2, 3. Okay, so now my vertex is at 2, 3, and my p-value, let's change to 2. Okay, so notice that my vertex is at 2, 3 now. Cool. And the focus is how far away from the vertex? Well, it should be p away. The distance from vertex to focus is called p, right? 1, 2. This graph is going by, like, these are halves, right? So half, 1, and then 1.5, 2, 2.5, 3. In fact, let's actually get rid of those. We're going to go up to our graph settings, and we're going to turn off the minor grid. And let's see if we can do this. Okay, cool. Now we have a little bit nicer of a graph. Cool. So now we can see a little bit more clearly that our focus is 2 units away from the vertex, and so is our directrix. Also, I wanted to point out the focal width, because that's kind of why this is called focal form, right? 4p. What is 4p in this case? 4p would be 4 times 2, right? Let's write this out. So we're going to have x minus h, so x minus 2, squared equals, and then we're going to have 4p, right? So 4 times p in this case would be 4 times 2, or 8. And then we're going to have y minus k. So that'd be y minus 3. Okay, so notice, yep, it came out in green, so that matches, right? So this right here, 8, that is my focal width. Check it out. At the focus, I got 1, 2, 3, 4, 5, 6, 7, 8. It's 8 wide at the focus. That's my focal width right there. P by itself, right? That 2 is this distance right here and this distance right here. Kind of neat.